Hi, my name is Victor and I am one of the product managers here at GitLab, and this video is to prepare product managers to think about Kubernetes and to be able to consider it for various products they want to build. Perhaps not only product managers, but like product people who are not very technical and not deep into cloud-native technologies. It will not go into much detail about networking and role-based access control at all. Instead, I will try to focus on the core principles and approaches built into Kubernetes and the enabling power. Most Kubernetes interactions and tutorials, as already mentioned, target engineers, not this one. This one is for product people who have heard that Kubernetes might be interesting and want to build a feature on top of it. You will get a bird's eye view of the main characteristics of Kubernetes and the sort of links to help you dive deeper into any of the topics. By the end, I hope with a bit of imagination, you will understand why the following snippets could be exciting, for example, for GitLab, and how we can reach it, what are the underlying building blocks within Kubernetes that allow us to make meaning out of that snippet. So these videos will have actually two parts, or at least that's what I planned today. The first part covers some very basic things that might be useful even if you want to start using Kubernetes as a user. The second focuses exclusively on more the basic building blocks and enabling power of Kubernetes. Still, I think it's hard to understand the second part without the first one, so let's start. First of all, I would like to clarify a myth, which is that Kubernetes is complex. I would say operations is complex. Kubernetes just made operations accessible to everyone because it's just YAML from the end user's point of view. Thus, Kubernetes seems to be complex. But if you think about it, there were virtual machines, bare metal servers, even before Kubernetes, that system administrators had to maintain, and they managed to build sizable infrastructure, huge infrastructure with that. And that was complex as well, extremely complex. They had to take care of deployments, of security, patching, and everything else. The same holds true for Kubernetes as well. And from a purely operations point of view, I would say Kubernetes is even less complex. Still, Kubernetes is hard, and there's a lot of YAML to write or read, and that's definitely there. First of all, a few words about declarativeness. I like to think about declarative operations that's something similar to serverless services. You don't know, in a serverless case, how the magic happens, what's running your code. There is just something that does it. It just happens. The same is true with Kubernetes. You don't know how you get the desired result. The cluster takes care of that. For this reason, you have to understand that GitLab CI/CD is imperative. You have to codify all the steps you want. You have to run commands that will do something, that will build you a Docker image. You don't just say that, give me a Docker image. You have to say that, okay, Docker run or Docker build, whatever. In Kubernetes, contrary to that, the YAML files describe the desired state, and the cluster takes care about reaching that state. This is the magic that we should understand. We describe the desired state. If you look at the YAML here, for example, you can probably figure out what that desired state is. And it's relatively easy to imagine an imperative code how to reach the same thing, which would say that create me a namespace and then provision a namespace service account in that namespace. Basically, that's what's described here. But with Kubernetes, you can be actually way more blunt, like a drunk seaman, and communicate in nouns. You just say that, like a grok, a namespace, and here you are. Here's your namespace. So following this declarative pattern has actually some very, very interesting benefits. Besides making it accessible to every user, because YAML is accessible, it even allows a program transformation of the YAML. And that makes it easy to scale to different scenarios with all kinds of tools that exist within the ecosystem. Here it's, I think, worth noting that there are some very widespread anti-patterns against this declarative approach in the Kubernetes ecosystem itself. Namely, the biggest one is the Helm package manager, which is not declarative. There's one more topic I would like to mention, which is whether having everything in declarative approach is feasible. I know that even within GitLab, not everybody thinks that it is feasible. I personally think that we don't know yet how to make it feasible, but it is feasible. And personally, I even have an idea. You might figure that out yourself. I'm not speaking about that in these videos. Besides the desired state, I would like to speak a little bit about labels and annotations. The YAML files can contain all kinds of metadata about the resources, and these are typically in the form of labels and annotations. It's very important to understand that labels are at the core of filtering of resources. This means that when someone wants to build a dashboard, for example, of course that dashboard can contain views to list all the pods or all the namespaces, but very likely it will have functionality to show the list of pods with a specific label, or even all the resources with a specific label, not just by their kind. And the kind was the namespace and the service account, if you look at it here. So labels and annotations are very important, and there are even recommended labels to use, and that already will hint you on the typical format of labels. So this was part one of this hopefully two-part series. Just a quick recap: declarativeness. Think about it, what it means to be fully declarative. What might be the edge cases there? Why is it powerful? How could we use that within GitLab? Where does GitLab fails declarativeness? And the other thing is about filtering. It's more just to understand that labels are there for us to help with filtering and building all kinds of tools that can interact through the filters. And that was the first part.